CBSE Service. First chapter is relations and functions. In this video, we are going to see about topic what is types of functions. That is one-to-one, on-to, bijective. Okay. Now, I am myself Kavitha. I can be called as Kavi or Kavitha, likewise, etc. One name is called by different ways. Likewise, these functions one-to-one, on-to, bijective can be explained in three ways. One is mapping method, another one is letter definition, another one is graphic method. How? Enter into the topic, we have to know that numbers, what is rational numbers, what is real numbers, integers, whole numbers, etc. First, real number is the whole part. It contains rational, irrational, integers, everything. Next, irrational numbers. Irrational number is which is root 2, root 3, etc. are irrational numbers. Rational numbers is it can be written as fraction form. 3 by 5. Likewise, it is a rational numbers. In that we have a natural numbers. Natural number means 1, 2, 3, etc. In that whole number means 0, including 0, it has a whole numbers. Integers. What is integers? Integers having a negative numbers. Minus 1, minus 2, minus 3. Okay, this is the numbers we have to remember and recollect it. Now enter into the topic. How we say the function is one-to-one using mapping. Mapping. For example, I am taking the number, considering the numbers domain, codomain. Both are natural numbers. Natural numbers means 1, 2, 3, etc. Here also 1, 2, 3, etc. I am giving the function f of x is equal to x square. In the function 4, 3 means 9, 4 means 16. Likewise, every input has distinct outputs. If I am taking instead of natural numbers, I am taking the integers. Now, integers means negative numbers. Here I have minus 1. Minus 1 square also 1. So both input have same output. So this function is not one to one. So every input has distinct output means it is a one to one. If it has a different output means it is not a one to one. Same like we can prove in the letter format. How we prove that in letter format? For example, I am taking the same function f of x equal to x square. X is in the form of natural numbers to natural numbers. Same. Instead of mapping, I am taking the if I am taking f of taking the natural numbers 1, 2. In function f of x is equal to x square. 1 square means 1. 2 square means 4. So f of 1 not equal to f of 2, then 1 is not equal to 2, it is true. This can be proved as likewise. Another method, numbers I am taking integers. Integers means negative numbers. F of minus 1 value x square 1. F of 1 also 1. So minus 1 is equal to 1 is false. It is not equal. So this condition is false. So it is not one to one. Likewise, we can prove this in letter format. How we prove in graph format? In graph form, we have two graphs: natural to natural numbers one graph, integers to natural number one graph. By observing the graph, you can notice that at most one point should be coincident in this graph. Here, likewise, we can say it is one to one and not one to one by choosing the graph method. Next, we are going to see about onto. 2 mapped to 2, 3 mapped to 3. Likewise, it will goes in natural numbers. If I am taking the function f of x equal to 2x, it is a onto. For f of x equal to x square, it is not onto. Same in the form, letter form. How we take it as in letter form? Belongs to x, there exists f of x is equal to y. Okay, likewise, we can prove that. If I am taking to 2x plus 1, then 2x plus 1 is equal to y. 2x is equal to y minus 1, x is equal to y minus 1 by. It is mapped from f is mapped from natural numbers to natural numbers. So integers x to y. So n is natural number means 1 to etc. If I am putting 1, 1 minus 1, 0. So x is comes 0. X is equal to 0? No. X is a natural numbers. Natural numbers does not contains the 0. So it is not onto. Likewise, we can prove in the letter format. In a mapping method, x is equal to 2 to 4, 5. 2 is mapped to 5. So here 1 and 2 are not mapped. So it is not onto in both the mapping method and the onto method. Likewise, in graph method, we can for natural numbers to natural number, f of x equal to x means how the graph is onto in both graph method. We can see it in the pictures. If every the points covers all the y-axis means that is called onto. So in this graph, every point is covered by this line. So it is onto. Next, we are going to do the problem. F from real numbers to real numbers. Real numbers contains negative, neutrals, everything. Here we have to prove it as one to one onto. We can use any method, mapping method or a graph method or letter form method. Here we take it as letter format method. Here f of x1 is equal to f of x2. I am taking 2x1 is equal to 2x2. 2 cancel, then we get x1 is equal to x2. This is one to one condition. If f of x1 is equal to f of x2, we have to prove x1 is equal to x2. That is f is on to one, f is 1 to 1. Next on to how we prove f condition. F of x is equal to y. F of x is equal to 2x, y. X is equal to y by 2. If I am putting y is numbers. Real numbers means I can put negative numbers, everything. If I put y is equal to minus 1, x is also get negative numbers, which is in the real numbers. If I am putting f is 4 means it is also real numbers. So for every y belongs to R, x is also belongs to R. This condition is satisfied. So it is a onto. So both so f of x equal to 2x is both 1 to 1 and on to. Next problem. If I am taking x as a y is equal to minus 1 means the square root becomes a complex number, imaginary numbers. So this condition is also not true. So it is not on to. Here for function f of x equal to x square, the function is not on to 1 and not 1 to. X in bracket that is given as greatest integer, mapping from real numbers to real numbers. What is meant by greatest integers? If I am putting 1.5 in the square bracket means I am getting answer 1. I am getting 1.9 also, the answer will be 1. If it is, that is meaning is a greatest integer. If it is if x1 is 1.5, x2 is 1.9 I am taking. So f of 1.5 is equal to 1, f of 1.9 is equal to 1. X1 is not equal to x2, but I am getting f of x1 is equal to f of x2, which is wrong. So f is not 1 to 1. For on to, how I prove? Minus 1.5 means that answer become minus 1. Likewise, it goes. But in real numbers, we will have the fraction numbers 1.2, 1.3, etc. But still, this y we did get 1 by 2, 1 by 3. So it is not onto. Every image should have a pre-image. So fraction numbers does not map it to the functions x. So it is not onto. Next, I am going, f has been given as natural numbers to natural number. Function is defined in two cases. One is odd cases, in another one is even cases. In odd, n plus 1 by 2, even it is n by 2. Now we have to show that it is 1 to 1 or odd to. Both condition we have to check. First 1 to 1. For example, I am taking two numbers 1, 2. 1 is not equal to 2. Likewise, x1 not equal to x2. I have to prove f of x1 not equal to f of x2. For example, if I am taking f of x1 is 1. So 1 is odd number. Odd number I am getting 1 plus 1, 2 by 2 is equal to 1. Another 2. 2 is even number. Even number means this condition. 2 by 2 also 1. So f of 1 is equal to f of 2. Here I am taking x1 not equal to x2. Then I should get f of 1 not equal to f of 2. But I am getting a contradiction result. So it is also not 1 to 1. Next on to. For on to I am getting two cases for odd case and even cases. In odd case, in general term, we can take it as 2k plus 1 belongs to natural numbers. It is a odd numbers we can take. Similarly, so if I am having to prove that f of x is equal to y, that condition satisfied means it is a odd term. For example, I am taking x4k plus 1 is equal to f of x. It is odd case. Then I am can taken as 4k plus 1 plus 1 by 2. So 4k plus 2. I am taking 2 by 2. 2 as common means I am get 2k plus 1. Denominator 2 cancel. So answer is 2k plus 1. F of x equal to y. So it is a odd case, it is a 2. For even case I am checking 2k belongs to natural numbers. So I am taking 4k. I'm checking f of 4k is equal to f of x is equal to y. I have to prove. So f of x means odd case 4k by 2. I'm getting 2k. So f of 4k is equal to 2k. So f of x is equal to y. I am proven that in for onto. So in both cases it is onto. So f of x is onto but not 1 to 1. So this function is not bijective. Thank you. If you like this video, share it. For more videos, subscribe it. Thank you.